Assalamualaikum and greetings to all. My name is Nurul Nadia Izzati Supian and I'm from Faculty of Chemical and Process Engineering, University Malaysia, Pahang. I'm here to present about the effects of fermentation period on bacterial cellulose production from all palm frond juice. This will be the outline of the presentation, which include introduction, methodology, result and discussion, and lastly, conclusion. Cellulose is a major biopolymer and has a tremendous importance in the global economy. Apart from plants, pure cellulose, often known as bacterial cellulose, can be produced by the bacteria Acetobacter and cultivated in a medium with carbon and nitrogen sources. The BC produced by this microorganism has unique properties such as high crystallinity, high tensile strength, high degree of polymerization, and high purity as compared to plant-based cellulose. Due to these outstanding and unique properties, BC has been attracting extensive interest from the researchers around the world. However, the standard medium for BC cultivation is expensive and requires additional supplement. Thus, it is crucial to search for a new cost-effective carbon sources for the cultivation of BC with a shorter fermentation time, as well as producing high yield of BC. Since all palm frond is generated abundantly throughout the years, it is crucial to potentially utilize it instead of leaving it unprocessed in the plantation. OPF juice is a good fermentation substrate since it is renewable, easily obtained, does not inhibit microbial growth, and contains no impurities. There are several factors that affect the yield and the productivity of the BC, which is the composition of the culture medium and the condition of the cultivation. The study was performed to evaluate the influence of cultivation time on BC produce by static cultivation of Acetobacter in OPF juice as the only nutrient sources. For the methodology, it includes the preparation of OPF juice, the production and purification of BC using different cultivation time, and the characterization of BC using FTIR and FSM. Next is the result and discussion, which is the effects of fermentation time on BC formation and pH changes. From the graph, it can be seen that the highest BC production was recorded at day 9 with 0.34 gram per liter of BC. The pattern of BC production is seen to be slightly decreasing after day 9. The figure also shows that the pH of the medium decreased from pH 4 to pH 2.96 as the cultivation time increased. The rapid decrease in pH in the first 2 days corresponds to the lag phase of bacterial growth. This decrease of pH is due to the formation of gluconic acid, acetic acid, and acidic byproduct during the cultivation, which makes the pH of the medium to be too acidic and inhibit BC production. Next is the FTIR spectroscopy analysis of BC. From the figure, it was observed that the FTIR spectrum of BC produced at different cultivation time to be similar as there is almost no difference among the BC spectra. It is shown that some absorbance punctuated due to the cellulose structure rearrangement. From the figure, it can be seen the absorbance which corresponds to the thrashing of hydroxyl group, thrashing of methylene bridge, bending of absorbed water, and CH bending. Native cellulose is known to be composed of two distinct crystalline phases, which are a mixture of alpha-1 and beta-1. The BC samples were found to be rich in alpha-1, where the alpha-1 of the BC samples at different cultivation times were varying in ranges of 0.62 to 0.74 as shown in Table 1. Lastly is the surface morphology of BC using FSM. From the figure, it was observed that the BC had a structure composed of fine cellulose fibers that were loosely and randomly packed. The average fiber diameters of the BC were ranged from 29 nanometer to 62 nanometer. These properties result in cellulose having strong traits such as water holding capacity, thermal properties, and mechanical strength. In conclusion, the highest species produce was obtained at day 9 of cultivation process, and the pH of the culture medium dropped from an initial pH of 4 to pH 2.96, which is due to the formation of acid byproduct. It was also found that the BC produce was enriched with alpha-1 and composed of fine cellulose fibers that are loosely and randomly paired. This result demonstrates the potential of utilizing OPF juice in BC production. And that's the end of this presentation. Thank you for listening.